This is Tech Math 2, and we're in Chapter 5. And because we're slightly behind, the plan today is do sections 1 and 2 today. So we'll see how that works. All right, so in section 1, we're factoring things. And in order to factoring things, we unfactor things. So we have rules. So if we have some constant times some variables, then that's the factored way. The unfactored way would look like this. So if I had something that looked like ax plus az plus ay, I could factor the a out and go that way. If I have something that's x squared minus y squared, I could factor that x plus y, x minus y. Now, each of these formulas are in the front cover of your book. So if you're doing a test or something and you can't figure out where you're going to figure out what you're supposed to remember, you look at the front cover of your book and it's going to be there. If I have x plus y squared, then that's going to be x squared plus 2xy plus y squared. So if I have something that looks like that, I would factor it x plus y, x plus y.
You got the wrong thing on the screen. Yeah.
If I was going to do that. And the class is now complaining that the camera's in the wrong spot, which happens every now and then. Very interesting. Now you're not seeing everything, are you? Very interesting. All right, so we're going to have to go and see if we can change that. We'll zoom it back to 150%. Is that better? All right, so now you can see everything. Very interesting how that worked. All right, so I can't write over there because you can't see over there. You can see there, you can see there, you can see there. So I'm going to have to quit about right there. Okay. One more rule. No, two more rules. X minus y squared is going to be x squared minus 2xy plus y squared. Now, if I were to do these guys over again, and I would say x plus y squared is x plus y, x plus y. And then I were to multiply that guy by that guy, x squared, go that way, plus xy, go this way, plus xy, go that way, plus y squared. You could see that you'd have x squared plus 2xy plus y squared. You can see that's sitting there. But the issue is we want to go directly from the squared term to looking like that, or the squared term. So we want to go directly, and we want to recognize this and go directly to x plus y quantity squared without any loss of generality. We just want to be able to, our brain needs to be able to do that. The guy on the top of page 118 is an interesting guy, but I don't recall ever needing to use it anywhere in the book. X plus y plus z squared, and I'm going to have an x squared plus y squared plus z squared plus 2xy plus 2xz plus 2yz. Okay, oh, excellent, all that there. So if in fact we see that particular general form sometime, then maybe we can go back the other way. But like I said, I've never seen a problem where I've had to do that. Then we have the x plus cubed and x minus cubed people. And the first thing that we don't remember is that there is a Pascal's triangle. And So Pascal's triangle says that the coefficients for x plus y cubed are going to be 1, 3, 3, and 1. Okay, so this is going to be x cubed plus 3x squared y plus 3xy squared plus y cubed. So I end up, I'm cubing these guys, so I have a x cubed, I have a squared term and a 1 term that adds up to 3 in exponents. I have a 1 and a 2 that adds up to 3 in exponents, and I have a 3 sitting there. But have you done Pascal's triangle ever in your entire life? Okay. We'll get back to that. And then again, this guy's in the front of your book. If I've got a minus sign there, I'm going to have x cubed minus 3x squared y plus 3xy squared minus y cubed. Okay, so back to if I have, I'm in the form a plus b to the n, and the n is equal to 0, then this becomes 1. So my Pascal's triangle has a 1. And if n is equal to 2, if n is equal to 1, then a and b are both 1. It's 1a plus 1b. If n is equal to 2, what I do is I bring down the 1 on the side. I bring down the 1 on the side. I take those two guys, I add them together and make a 2. And so when n is equal to 2, this a plus b to the squared is going to expand a squared plus 2ab plus b squared. And then if I go down another 1, this is 3, 3, 1. What I'm doing is I'm adding the 1 and the 2 to make 3, adding the 1 and the 2 to make 3. And then if I have a plus b cubed, that's going to expand a cubed plus 3a squared b plus 3ab squared plus b cubed. And then I can do it again, 1, 4, 6, 4, 1. And I have a plus b to the 4th. And then that's going to expand a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. And I can keep on going. I can keep on going with Pascal's triangle down to 11 or 12 or 13 and find the coefficients of something that's a plus b to the 4th to the 12th power. I could do that. I could make that triangle. It's a very simple thing to do. And then I'd have the coefficients that go along with that expansion. Now, why would I want to do something like that anyway? Well, it turns, this is, if I go 1 minus p, where p is the probability of getting a particular card in poker. Okay, if I do that, then I come up with the probability of pulling an ace. So 1 minus p, the probability would be 1/13 of pulling an ace. If I square that, that'd be the probability of pulling 2 aces. If I cube it, it'd be the probability of 3 aces. If I go to the 4th, it's the probability of 4 aces. So you end up using the binomial theorem in your ability to assess how much money you're losing, which is going to be significant because you don't win at cards. Okay. Anyway, but in this particular chapter, we're not going above the cube, x plus y cubed, and that's in the front part of your book. Okay, so we'll look at problem number 1, and I want to find the product. Minus 8x squared, 5x squared cubed, 5x cubed, 9x squared, 10x, minus 40 x to the 5th, because the exponents add, plus 72 x to the 4th, minus 80 x cubed. Okay, number three. Number three, 6x cubed y to the fifth times 4xy, 4x cubed y squared, 9x to the fourth. Okay, so I've got 24 x to the fourth y to the sixth minus 24 x to the sixth y to the seventh plus 54 x to the seventh y to the fifth. So I'm just multiplying those guys.
7 on 4.
Oh, well, that's okay. It doesn't matter. Okay, you want me to do it with a 7 there. All right, so now I got to go 7 times 6, and 7 times 6 is 42. All right, is that better? If I didn't assign it as homework, you wouldn't have cared, right? Yeah, typical. All right, well, let's see. We'll drop down to 27. 3a cubed plus 10b squared cubed. Okay, so I'm going to have 3a cubed plus 3 times 3a cubed squared 10b squared plus 3a cubed times 10b squared plus 10b squared cubed. And then I'm going to rewrite that. And let's see, 3 cubed is 27. So I got 27 a to the ninth plus I have 9 times 3 is, what happened to my 7? Who took my 7? Alright, so I got 2, I have 3 squared, which is 9, times 2, 27, times 10, 270 a to the 6 b squared plus I've got 100, I've got 9, so I got 900 a cubed b to the fourth plus 1000 b to the sixth. Alright, so now I'm done with my expansion. Now, the issue here would be if I saw this expansion, could I collapse it back to this guy? Okay, can I go the other way? And luckily we don't have to go the other way until next semester, but that'd be something to look about. So we do these problems to get down to the answer this way, so that when we see that later on, we can go back the other way. So what I would do is if this is making sense, then that's fine, move on. If it's not, do all 48 homework problems, one right after the other, and then throw them away when you get done, so that your mind has soaked into it all those things that you saw, so that when you see it the other way, you can go the other way easily. All right, well, enough of that, right? We look at, no, that's too easy. Oh, there's some cool ones there. Look at 43. So I got 3x squared minus a half y times x squared plus 2/3 y. Okay, well, first guy times first guy. 3x to the fourth plus 2x squared y. Okay, minus 1/2 x squared y minus 3, 6, 2, 6, 2, 6 y squared. Alright, well, it seems like we can combine some terms here. 3x to the 4th plus 1.5 x squared y minus 2 over 6y squared. I'm not sure that I like that. I think I'd rather have this be 3 over 2 rather than 1.5. Is that better? Less ink that way? Yeah, less ink. Alright. So you want me to do 47 next? Okay, I'll do 47 next. 47. X squared, 1 plus x squared, squared. Alright, so I got x squared times 1 plus 2x squared plus x to the 4th. I'm going to write it the other way. X to the 6th plus 2x to the 4th plus x squared. Now, in a future chapter, we're going to have this problem. We're going to have to factor it. So we'll factor it x squared times x to the 4th plus 2x squared plus 1. And then I'll say that's 2x times x squared plus 1 squared. And we got back to where we were. All right, we'll do 48. And then we'll go to the next chapter. X squared 1 minus x squared cubed. All right, so I've got x squared times 1 minus 3 times 1 squared times x squared squared. No, x squared, not squared, to the first. Plus 3, 1 times 1 times x squared, because the minus sign is taken care of in our form, minus x squared cubed. Alright, so I've got x squared, I've got minus 3x to the 4th. I've got plus 3x to the 4th. I do. No, I don't. Yes, I do. 3x to the 6th minus x to the 8th. All right, there we go. Did it. All right, now we're going to move on to section 5.2. And we have another set of rules. It looks like this is where we undo everything we do in section 1. So I've got something that looks like that, and I factor out the A. And I got something that looks like this, and I'm going to factor in x plus y, x minus y. Okay, does that cover everything? Oh, and if I have something that's x squared plus 2xy plus y squared, I'm going to factor that x plus y squared, and if I have x squared minus 2xy plus y squared, I'm going to factor that to x minus y squared. Now all those formulas are in the front cover of your book, so they shouldn't be too much of a mystery. If I have x squared plus y squared, can I factor that? So if I have x squared minus y squared, it factors x plus y, x minus y. if I have x squared plus y squared, can I factor it? The answer is not until chapter 14. Okay, so in chapter 14 I have imaginary numbers, and I can factor this x plus iy times x minus iy. So now I times I is minus 1, and there's another minus sign, so that becomes positive, and the inner terms go away, and I can factor. But I can't do that until I get to chapter 14. But in chapter 14, I'm going to be able to do that. Okay, so we'll look at number 1. 6x plus 9y. I see that I have a common factor, it's 3. So I can 2x plus 3y. I'll look at number 2. I've got 15x minus 20. I notice I have a common factor, it's 5. 3x minus 4. Moving on to 6. Oh, I guess not. I got to do 3. 3, I've got 10x plus 25y minus 45z. I see I have a common factor of 5. So I can take out the 5. 5, 2x plus 5y minus 9z. Okay, now we'll look at 6. 10x squared plus 25x. Okay, I have a common factor of x, and I have another one of 5. So I can take 5x out, and I'd have 2x plus 5. I'm going to move down to 12. I got 15 x to the 7th y cubed minus 6 x to the 6th y squared plus 12 x cubed y z. I say I have a common factor of 3. I have a common factor of x cubed y. Okay, what do I have left over? I have 5 x to the 4th y squared minus 2 x cubed y plus 4 z. Okay, I'm just not doing anything particularly cool there. Okay, we'll look at 14. Look at 14 next. Number 14, x squared minus 64. I recognize it as x squared minus 8 squared, and I factor it x plus 8, x minus 8. I'm in the section where I'm doing the factoring of the differences of two squares. So when I see 64, because I'm in that section of the book, I immediately think, oh, that's 8 squared, and then I continue on with the factorization. What if I had x to the 4th minus 64? What would I do then? Well, I'd recognize that as x squared minus 2 squared, 2 cubed squared, 2, let's say that's 8, 8 squared, 2 to the 4th is 16, right? So this would be 2 cubed squared. Okay, that's how I would recognize it. Yeah, because 2 to the 6 is 64. All right, then I can factor in x squared plus 8, x squared minus 8. And then 8 isn't the square root of anything, so I would leave it at that. Or I could get even more weird if I wanted to, right? Oh, okay. I'm already weird enough. Don't get any more weird. Okay. So we'll do number 20. No, we won't. We'll do 21. 4 capital R squared minus 4 little r squared. And we say, well, I recognize that as 2r squared minus 2 little r squared. So that's going to factor 2r plus 2 little r times 2 big R minus 2 little r. So again, because I'm in the section dealing with the differences of squares, I'm going to first go to that particular idea that I have a difference of squares. Okay, we're going to look at number 30. C squared plus 22c plus 40. And I'm supposed to factor that? I don't see where that belongs in this section, do you? Probably not. Well, anyway, if I'm going to factor it, in order to get a c squared, I have to have a c there, right, and a c there. In order to get a 40, I'm going to have to go 1 times 40, or 2 times 20, which is what I'm going to pick, plus 2 plus 20. Because when I add 20 c's and 2 c's, I get 22 c's, and I'm done. If I didn't come up with one of those, I'd keep on going. So 4 times 5, and then I can find the negative numbers that would happen. So trial and error and guessing is what I'm doing. Let me think about this now. Does our calculator do that? And the answer is yes. So if I turn on my calculator and I go to second function polynomial solver 1, and I can put in a 1 for my A, and a 22 for my C, and a 40 for my, well, 40 for the last guy. I tell it to solve. It'll tell me the answer is minus 2 and minus 20. So it says, my calculator says C is minus 2 and minus 20. All right, well, in order for C to be minus 2 and have that equal to 0, it has to be C plus 2. And in order to have C plus 20 to be 0, C has to be minus 20. So that checks my work. So I don't necessarily have to go and do this. I could just go and put it in my calculator, ask it for an answer, and life would be so much better. All right, we'll do 33. A squared plus 3a minus 4. And that's going to factor. In order to have an a squared, we have to have an a on the front end. Now, to get a minus 4, I could go minus 1 times 4, or I could go minus 2 times 2, or I could go minus 4 times minus 1, or I could go minus 4 times minus 1, minus 4 times 1, or I could go the opposite way. But if I look at the sum of those two, I see the sum of those two is my 3, so that's what I'm going to want. Plus 4 minus 1. And again, I could have just as easily put that in my calculator and figured out what the a's were and done it the other way. 35. 2x squared minus x minus 6. All right, well, I'm going to need a 2x and I'm going to need an x. And to get a minus 6, I can go minus 1 times 6 minus 2 times 3 minus 3 times 2 minus 6 times 1. But when I get done, I want a -1 sitting there. I got this 2 over here. All right. So if I go with -2 plus 3, now I'm going to get 3x. I'm going to get -4x. That's going to give me the -1, and I'm done. Now I could have taken my calculator, gone to second function polynomial solver. The first guy, a is a 2, b is a -1, c is a -2, -6. -6, tell it to solve, and it's telling me that x1 is -3 over 2, and x2 is 2. And then we could say, well, if x2 is 2, then x -2 has to be 0. And if x1 is -3 over 2, then -3 over 2 plus 3 times some coefficient that I don't know has to be 0, and that coefficient has to be a 2, and that's how I get that. Okay, so I could have used my calculator and worked backwards if I wanted to work backwards, but it is really too much work to work backwards, so I probably wouldn't do that. 42, 16g squared plus 8g plus 1. All right, now I got to work on the other side. So 16 could be 1 times 16, 2 times 8, 4 times 4. Well, 4 times 4, when I add them together, I get an 8. So I'm going to call this 4g plus 1, 4g plus 1. And then I'm going to say, well, gee, that's 4g plus 1 squared, and then I'd be true to my calling as a math major. So I could do that. 44th. 6m squared minus 13m plus 5. All right, now I got to go both ways. So 5 can be 1 times 5, 5 times 1, minus 1 times minus 5, or minus 5 times minus 1. And 6 can be 1 times 6, 2 times 3, 3 times 2, 6 times 1, or the same combinations with minuses in both places. So I got 8 possibilities over here. I got 5 possibilities over there. And when I get done, I want a minus 13. Okay, well, if I add 6's and 5's, I'm only going to get 11. But if I go 2's and 3's, and I go 5's and 1's, I could have 5 times 3, which would be a 15, minus a 2, which would be a 13. Okay, now it's just a matter of getting the negative signs in the right place. So I'm going to go 2m, 3m, and then I want 5, 1. All right, but that's not going to work. Okay, so that won't work because they both have to be negative or they both have to be positive. So that won't work. All right, so we'll do it again. I got a minus 13. Did I write the problem down right? Yeah, I did. All right, so I got a minus 13 there. 6 times 1 6 and 5. Oh, right. All right, okay. So if I go 3, 2, minus 5, minus 1. Now I got minus 10, minus 3 for minus 13. I got plus 5, I got a plus 6, and I'm all done. Total luck, I know. Number 50. 24m squared plus 34m plus 10. I see I have a common denominator of 2. So I'm going to take the 2 out first. 12m squared plus 17m plus 5. All right, so 2 times something times something. And the 5 could be a 5 times 1 or a 1 times 5. And the 12 could be a 1 times 12. And I'm done because 12 and 5 is 17, right? So I could have m, 12m. I could have plus 1 plus 5. And now I got 12m, 5 more m for 17m. I got a 5 on one side, 12 on the other side, so I'm all done. We will look at, really, 55. 55. 9x squared, 48xy squared, 64y to the 4th. Okay, well, I guess we can, wait a minute. We can take out an x, right? That's about all we can do. Did I write the problem down right? Yeah, I did. I wrote the problem down right. We can't factor out an x. We can't factor out a 3. Yeah, we're pretty much hosed here, aren't we? All right. And we can't put it in our calculator to have it tell us what the answer is unless we have a smarter calculator than the TI-36. All right, well, we're going to have an x here with something in front of it, and an x there with something in front of it. And we're going to have a y squared and a y squared with something in front of it. All right, now, okay, I see it. If I go 3, 3, 8, 8, then I've got 64, I've got a 9, and 12 plus 12 is plus 48. So that's not going to work. I want negative, negative. All right, so I still have plus 64. I still got plus 9 squared. And I've got minus 48xy squared. Isn't that lovely? Totally lovely. Now, could I have recognized that as x minus 8y squared, the quantity squared? Maybe I could have. I could have gone and said, this is 3x squared minus 48xy squared plus 8y squared squared, and then I'd say, well, gee, in here this is just 2 times 3x times 8y squared, so I'm in the right form, and this becomes 3x minus 8y squared, the quantity squared. That would have been I don't think my mind would have worked that way. But it should have worked that way. But I'm sure it wouldn't have. Okay. 59. X to the fourth minus 81. Okay, so I recognize that it's x to the fourth minus 3 to the fourth, right? So that'd be x squared squared minus 3 squared squared. So I could write that as x squared plus 9 times x squared minus 9. And then I could recognize this guy as x squared minus 3 squared. So I could rewrite it x squared plus 9 times x plus 3, x minus 3. So I could do that. That will work out just fine. Why don't we do 63? 63. T to the fourth minus 13t squared plus 36. Okay, so that's going to be t squared 36. 36, 1 times 36, 3 times 12, 4 times 9, and 4 plus 9 can be that number there. So minus 4 minus 9. Now I recognize this as t squared minus 2 squared times t squared minus 3 squared. And now I can write it t minus 2, t plus 2, t minus 3, t plus 3, and now I'm done. Well, that was okay. 64, and then we'll take attendance. Number 64. X to the fourth minus x squared minus 12. All right, so that's going to factor x squared. I look at the 12. 1 times 12, that doesn't do any good. 3 times 4. Okay, if the 4 were negative, then I'd be there. Okay, so plus 3 minus 4. I recognize the 4 as 2 squared. X squared plus 3, x plus 2, x minus 2. Okay. Fast enough? And again, for those who lacking in math skills, you just work all the problems. You just work them all. That way you've done it. That's what when you're doing this with your high school kid as they're growing up and you're doing the math with them. That's what you're going to do. You're going to go back and work all the problems in the problem set with them. That's going to change their SAT score, change their ACT score. You're going to get scholarship money. You're going to be a wealthy man. No? Yes, definitely.